Welcome to Project 4, Part 2. In this section, we'll look at the lengths of hospitalization of children with infectious fever. We're looking at probability as it relates to quantitative variables. Our research question in this case is, what was the probable length of hospitalization for a child admitted with a diagnosis of infectious fever in 1861? We're going to start with a standard 5-number descriptive statistics summary. We'll create a histogram. We'll calculate the probability for each range of the histogram, the probability that a term of hospitalization will be less than a given value that we'll choose from our data set, and then calculate and interpret the z-score of a given number of days of hospitalization. Again, we're using the data from the hospital records from the children's hospitals in Victoria and London. We've got a selection of data specifically from 1861, and here I've arranged to sort the data by the length of stay in days. And the way I did that was by selecting all of my data, going to the data column and choosing sort. I say yes, my data has headers, and choose length of stay in days. I could also have sorted by any of the other criteria here. I also want to filter by disease group, and Excel 2010 has an interesting feature here that will allow me to type in the value I want, infectious fever, and this will select all the items that include infectious fever, some of which will also include another value. Once I've done this, I can see that I have a subset of the data showing, and I can select just the data that matches my criteria and copy. And this is a non-contiguous selection. You can see that in places where it's skipping data, those double marching ants lines show that it has skipped the data that is not visible. So when I go to a new worksheet and I paste, I can paste values. So now I have a list of just the infectious fever entries, and I can see that I have 125 of them, one less than 126, because my first row is my headers. This is the data that I'm going to use to actually run my various calculations on, because this is now a contiguous set of data that matches the criteria that I want to use. So I'm going to start by doing some simple descriptive statistics. And all of these formula are going to reference the previous spreadsheet. So that's named infectious fever. Because that has a hyphen in it, which would be interpreted as a minus sign, I need to put single quotes around the name of the data sheet that I want to use, and then an exclamation point, and then the range that I want to draw values from. So here I'm doing a count, and then I'll do an average to calculate the mean, a median, mode, the minimum and the maximum, and the standard deviation. And I'll use these for different purposes. The mean is fairly obvious. We've talked about that several times in class already. The mean plus and minus the standard deviation will give me the range that will contain 68% of the data. And the minimum and maximum are useful for determining what bins I want to use when I'm creating my histogram. So here my lowest value is 0, my maximum value is 69, so I'm going to use ranges of 10 each up to 70, and that will enclose all of my values. So I'll have 10, which will be all of my values that are less than or equal to 10 will be included in this bin, and then 20, all the values not included in this bin, but up to 20 will go in this bin. So that'll be 11 through 20, 21 through 30, and so forth. In order to create the histogram, I am again going to use the special features under Data, Data Analysis, select Histogram. I'll start by saying, what will my input range be? Now this is going to come from the infectious fever data. So again, I will select length of days, And that can include blanks, for example in this case where Ann Rose doesn't actually have a number of length of days, but must not include the label at the top of the column. And then bin range, and that is going to be just this group of cells here. Again, not the label at the top, just the numbers that I want to use. And then I can specify an output range. That's where my frequency table will be produced. I can also have it generate on a new worksheet or even in a new workbook. And it can be helpful at this point to generate chart output as well. Click OK. If you have any data already in your output range, it will be overwritten, so Excel warns you about that. I've done this calculation before. So it creates the calculation for me and then automatically creates a histogram for me with the appropriate labels. Now what I've done is I've calculated probability by taking the frequency value that was calculated and dividing it by the total. And then I've also, on top of the histogram chart that was created for me, I've added some lines. And in order to do this, go to Insert and choose Shapes, and there is a line tool. And with the line tool you can actually draw anywhere on your spreadsheet, but in this case I'm drawing on top of the chart itself. So in this case I'm estimating. I'm going to estimate where I want my lines to be based on the value that I've calculated for my mean at about 22, so a little bit more than the base. Remember, this column represents 20 to 30, so just a bit in from 30. And then my mean minus standard deviation is a bit more than 6. So we see that here in the 0 to 10 range. And then my mean plus standard deviation is just about 38. So I've put it over here in the 30 to 40 range, most of the way towards the edge. So this gives me a nice picture of what I can expect to see in length of hospitalization in days. Most of my values are in the 10 to 20 range, even though the mean itself is a bit higher than that. So this is reflected in the median value of 19. That's in the 10 to 20 range. And then I can sort of see the shape of the data, and there's a spike over here. So this is an asymmetrical curve. I wanted to calculate the probability of a stay of 20 days or less. And the way I calculate that, I6 plus I7, here's my I6, I7, and what I've done here is just said 20 days or less will be the first two bins. So all I need to do is just add these two probabilities, and that tells me what the probability is that a patient's stay will be 20 days or less. If I wanted to say, what's the probability that the length of stay will be more than 60 days? That would be 3%. More than 50 days, that would be 6%, 3% plus 3%, and so forth. One of the things that you can do as well is calculate and create a graph that gives you a kind of curve. Now this is an approximation of what a normal curve would look like. I made a chart that is a scatter point chart. So here we have a number of data points, and for each bin, the 10 to 20, the 20 to 30, and so forth, for the number of days, I have a frequency count for the number of patients who stayed for that number of days, and I can see how the slope drops off here. Now this is the length of stay in days for my entire data set, not just infectious fever. I needed more data to get a smooth kind of line. And then to get that line for my chart type, move across on XY scatter, and there is a scatter with smooth lines, and this will connect the dots for me, and this creates that curve. So you can see that with the overall data set for hospitalization, the curve is even more skewed than what we saw with the infectious fever. The last thing that I want to do is calculate the z-score. Now, the z-score is a special kind of measurement that we use. It's called a standardized measurement. And the idea is that when you have different kinds of data and you're trying to consider how likely or unlikely an event is, a specific event out of your data set, you want a standard way of measuring that. So the standard measuring stick that we're going to use is the standard deviation. So what we're going to do is we've got our count, we've got our mean, we've got our standard deviation, mean plus and minus. I'm going to look at this particular entry. So here we have George Ryan. He had measles at the age of 5 years and 0 months. He was there for 18 days. How common, how probable is it that someone would be staying for 18 days out of all of the infectious fever patients? And the way we calculate is simply we take our number of days that he has stayed minus the mean divided by the standard deviation. Let's think about how that's going to work. We've got 18, so George has stayed 18 days. The mean is over here. We take 18 and subtract the mean. That gives us the difference between George's value and the mean. But we want to know how we're going to measure that difference with reference to the standard deviation, which is a bit larger. So here again, standard deviation is 15. The difference between George's value and the mean is about 4. And then we're going to divide that by the standard deviation. So this is about 16. 4 out of 16 is about a quarter. And in fact, we see, since this is going in the negative direction, it's below the mean, it's 0.24%, about a quarter of a standard deviation below the mean. That's it for this week. This was a fairly lengthy set of instructions, but I hope at this point you can understand that this is not a very complicated topic. It's all about calculating probability by looking at a whole set and looking at a subset and comparing the two in terms of proportion of incident, and then comparing the two in terms of standard deviations and means when we're using quantitative variables. Thanks a lot. See you next week.